Good evening and welcome to the Q&A session 17 from the chapter of Heat and Thermodynamics. The topic is the determination or finding the latent heat of fusion of ice when it is mixed with water. So based on this topic, I have written here one question for this session, and the question is 0.5 kg of water at 20 degrees centigrade is kept in a calorimeter. 100 gram of ice at 0 degrees centigrade is added to it. All the ice melts and the final temperature of the water is 5 degrees centigrade. So we have to find the latent heat of fusion of ice if the specific heat capacity of water is 4200 joule per kg degree centigrade. So इस क्वेश्चन में there is 0.5 kg of water in a calorimeter at 20 degree centigrade और इसके अंदर हम 100 grams of ice डाल देते हैं which is at 0 degree centigrade. The ice melts completely and the final temperature of the water mixture is 5 degrees centigrade. So in this question, this 0.5 kg of water which is at 20 degrees centigrade, it will lose heat and its temperature will become 5 degrees centigrade. So heat lost by the 0.5 kg water. This is equal to 0.5, that is Q is equal to mc delta T. So m is 0.5 and C is the specific heat capacity of water, which is equal to 4200, and delta T here will be equal to 20 minus 5. So the heat lost by this 0.5 kg of water, this will be equal to 4200 into 0.5 into 15. This is equal to 31,500 joules. Now, when the ice melts at 0 degree centigrade, it will absorb the latent heat. And when this ice gets converted into water at 0 degree centigrade after melting, then it will again absorb the sensible heat in order to raise its temperature from 0 degree centigrade to 5 degree centigrade. So the heat absorbed by 100 gram of ice plus the melted ice. This will be equal to, the heat absorbed by the 100 gram of ice will be equal to the latent heat, and that will be equal to, now here 100 grams is there, so I will be converting into kg, that is 0.1 into L. L is what? It is the latent heat of fusion of the ice which we have to calculate. Plus this melted ice will absorb the sensible heat and its temperature will rise from 0 degree centigrade to 5 degrees centigrade. So this is equal to 0.1 into 4200 into delta T. Now delta T here it will be equal to 5 minus 0, that is 5 degrees centigrade. So the total heat absorbed by the 100 gram ice and the melted ice, this will be equal to 0.1 L plus 4200 into 5, 4200 into 5 into 0.1. This is equal to 2100, and this will be in joules. Now, if no heat is lost in the surrounding, then heat lost by this 0.5 kg water will be equal to the heat absorbed by the 100 gram of ice plus the melted ice. So here 31,500, this will be equal to 0.1 L plus 2100. So from here I will be able to find the value of the latent heat of fusion of ice. So the value of L will be equal to 0.1 L. This is equal to 31,500 minus 2,100, and this is equal to minus 31,500, and this is equal to 29,400, or we can say that the latent heat of fusion of ice, this will be equal to 294,000 joule per kg, or we can say that the latent heat of fusion of ice, this is equal to 2,94,000 joule per kg. So in this question, the most important thing was the utilization of the concept of heat lost is equal to heat gain, provided no heat is lost in the surrounding. So in the next session, I will be discussing about the heating curve. So till then, have a nice day. Bye.